right? So now we are going to learn how to analyze a space frame in the STAAD. So I have given a typical space frame here. So I have actually this is Y. So the coordinate system I have considered similar to the STAAD Pro X, Y, Z, and this is the frame. So in one direction the bay width is 3 meters, the perpendicular direction the bay width is 5 meters, and it is subjected to a different loading. So there is a UDL. So this is the UDL PZ in the Z direction, 10 kilonewton per meter on this 5-meter beam, and there is a QY. So there is a vertical in the Y direction, there is a triangular load 10 kilonewton per meter, and in the Z sorry, this one is X direction. So this is X direction. So Fx is 15 kilonewton, a point load. Okay, and the column heights are three. The three columns are same for 4 meters height, and one column is 6 meters, and three supports are fixed supports, and one support is triangular support. So this problem will analyze, will model it, and apply the loads and analyze it, and in the STAAD Pro. Coming to the column dimensions, the column dimensions, so I will note down here. So all columns 400 by 400, that is 0.4 meter by 0.4 meters, and all beams, so 0.23 by, this is 0.23 by 0.45. Okay, so for simplicity, just I wanted to concentrate more on the loading and also the modeling, so the properties, definitions and all, so I made it simple in this problem, right? So now I am opening the STAAD frame and going to the new project, space, and I will say this is space frame. In the same STAAD exercise, go to next, add beam, finish. So I will try to develop this space frame by having a single node. From the single node I will try to develop. I click here and close this one so that you will get a single node. I will consider this beam, whatever the column is there, the footing at this location, so this joint is 0. So now I will try to create this 4 meter in the Y direction. So there is one more node I have to create, and between those two nodes I have to have one beam element 4 meters. In the Y direction 4 meters I have to have one more node. So I will select this node and click on to this translation repeat in the Y direction for 4 meters. If you click on this link step between those two nodes, beam element will be created. Then I'll say OK. Okay, so in the Y direction 4 meter. Now I got this point now. So in the Z direction, this is the Z direction. In the Z direction for 3 meters, I have another element. So I select this node. In the Z direction, I will consider 3 meters, link step, OK. Okay, in the Z direction. So, and the column height at this node is 6 meters in the minus Y direction. So I select this node, translation repeat, and this is minus 6, link step, okay. Sorry, this is X direction. So I don't want this, go to Control Z. Now you translation repeat in the Y direction, minus 6, link step, okay. Right, so now whatever this beam I have here, so whatever this beam is there, the same thing I will translation repeat for 5 meters in the X direction. So that is, I'll select this beam and go to the translation repeat for 5 meters in the X direction, link steps, okay, right? And here from this node I can drop 4 meters down and 4 meters down, so that I will select this node here, press Ctrl, select this here, go to translation repeat in the Y direction, and this one is -4, link step, okay, right? So now the frame is created here. Now I have to give the properties. So the modeling is completed. Go to the general, go to property, define property. There are two properties. One is 0.4 by 0.4, that is for columns. Add. There is another property 0.23 by 0.45. So 0.45 is the depth, 0.23 is the width for beams. So this property is for beams. Say add. Now first property, I will select these nodes. Okay, you can having any problem in selecting these nodes, simply what you can do is go to select, press beams parallel to Y, so that you will have the columns will be selected, and assign, right? And the remaining whatever is there, so that I can do by selecting like this. I'll go to the front view, select only the beams alone, and confirm it with your isometric view. All beams are selected here. Again I'll do it. So for selection, it is always you select the property first, then you select the elements afterwards, then assign to the selected beams. Yes, okay. Then after supports. So for supports, create a support, fixed support, add. So this support assign to the cursor. So go to this node, and if you are not able to see the nodes, simply you press Shift K so that you can see the nodes. Press here, and there is a fixed support here, and you create a pin support, press add, and this pin support you assign at this location. Okay, so now the important thing is go to the load definition. So go to the load case, just you add the primary load case. I will say this is dead load, add. Then there is another load case, live load, add, close. So in the dead load, just you add the self weight, so that whatever the beams and column dimensions are given self weight automatically, it taken care by the STAAD. Okay, then you select this self weight and assign to view, so that all the members the self weight will be added, right? So then in the remaining whatever the loads are there, I will try, since it is not mentioned in the problem, I will give it in the live load case. And there are three different loadings are there: UDL, UVL, that is a triangular load, and also there is one point load. So one by one, just I will try to define. So first one is the UDL. So go select the live load and select the add, then go to the member load. The UDL will be there in the member load, and this load is -10 kilonewton per meter, and it is throughout the beam. So you need not to give the values of D1, D2, D3, but it is in the Z direction, so that simply you say this ZZ direction. So then you add. So immediately you try to select, and here this is 5 meters, which is parallel to the x-axis, and it's a left side of the beam. Okay, so this is parallel to the x, and the left side means this one. I'll select this, then assign to the selected beam. And since I have given minus z, but it is actually the plus z I have to give. So you can anytime, if you want, if you give a wrong value or maybe the direction, you can change it. Now this is the direction of the UDL. Then the QY, that is the triangular loading in the 3 meter beam. So this is the 3 meter beam. So first I have to create the triangular load. So first click onto the live load, then press add, and then go to member load, and this is linearly varying. So there are two options are there. One is trapezoidal one, the other one is the triangular one. So you choose the triangular, that is W3, and this value is 10, and actual y direction is up, but my load is acting down, so that is minus 10, and in the y direction only. Then add, close. Now I select this member, assign to selected beam. Yes. So this is done. Then there is another loading, fx, so that is 15 kilonewton, so on this one. So that again I'll press live load, add, there is a load, and it is a concentrated member load and concentrated force, and this value is 15. So if you go back and check, x value is in this direction, but 15 is in the opposite direction, so I have to give minus, and this is x direction. Okay, and there is d1 d2 is there. So first I will try with 1 meter from the top. So I'm assuming that, so my the node here is starting from the top, so simply I will say this is d value is 1. Then add, select this load, select the member, assign to the selected one. Yes, so this is fine. Top, from the top it is 1. Sometimes if the node starts from here, and if you feel that you have given a wrong value, then simply you double click it and you can change the values here. Okay, so now the loading is applied. Go to analysis, then print all. If you require, you can give the perform analysis, then you have to analyze this. Okay, now 0 errors and 0 warnings, and go to the post processing, and here I have not given the combination. Then just you go back and give the combination in the load definition. Go to load case, add, define combinations here. So this value is 1.5, and give these two values, so that is the combination. All right, then again you analyze it. So go to the post processing, you can select all these things, and if you want to see the movement in z direction, this is the beam, and the movement in the z direction, and the movement in the x direction, and the shear force. Okay, if you want to increase the scales of this, now it is in the F5 shear force in y direction. There is one option called scale here. Click on the scale, and in the shear in the y direction I decrease this value, and there is one option apply immediately. Immediately you can see how the scaling is changing for the shear force. Then apply. Suppose if you want to see only the uh, bending moment in y direction, so the bending moment y direction, scale, bending y direction, apply immediately. Right, this is sorry, y, I have to click on this z. Okay, so this is how the bending moment diagram is there. Right, so basically for beams we will consider mz is the most important, because the bending axis will be z. So it's all depends on generally the modeling, loading, etc will be given as per the global coordinates, that is xyz, but whereas the STAAD will present the results in the local coordinates.